Forward. Okay. So we are talking about muscles. We're talking about how they contract, right? And mechanisms for sliding filaments. Now, we said these are skeletal muscles, right? So we have to get some sort of a message from our brain to the muscle. That junction, or that place where the nerve from your brain meets your muscle, is called the neuromuscular junction. That's where an axon from your nerve meets up with a motor neuron, or I'm sorry, of a motor neuron meets up with the motor end plate of the muscle. So it's basically just where the axon coming from the nerve from your brain meets up with the motor cell for the muscle. What's going to happen is wherever this occurs, wherever any neuron interacts with any other cell, it never actually touches the other cell. It comes really, really close, but it never touches it. And so between the neuron and the muscle fiber, or the muscle cell, there's a little space, and that space is called a synaptic cleft. And what's going to happen is molecules coming down the length of that neuron are going to diffuse across that little space, and they're going to bind to the muscle cell. Those molecules are called acetylcholine in this case, okay, ACH. So ACH is making its way down the length of the neuron. It gets all the way to the end of the neuron, and it diffuses across that little space to get to the muscle cell. Okay, and when it binds to the muscle cell, it generates a little electrical impulse on the muscle cell that travels through the T tubules, and it goes to the sarcoplasmic reticulum, and it allows calcium to flow out, right? And we know that once calcium flows out of the sarcoplasmic reticulum, that it binds to troponin and tropomyosin, which leaves the active sites of actin available. So myosin can now grab onto actin and shift in, right? And pull those actin thin fibers closer to the middle. So here is the neuromuscular junction. You can see this is a neuron. This is the axon of the neuron. Here's where it ends, and it ends at one of these muscle fibers. Now you can see there's one neuron for one muscle fiber, which means it's going to multiple myofibrils. Okay. And what's going to happen is there's always a little bit of space between the axon and the muscle fiber. So here's your axon here, right? And here's your muscle fiber. That little space, which is brown in this picture, that's called a synaptic cleft. Inside the axon and all these little bubbles is acetylcholine. And the acetylcholine is going to get into this space, the synaptic cleft, get across that space and bind to these little purple receptors that are on the surface of the muscle cell. Okay, so here you can see the acetylcholine getting emptied into that space, and it's binding to these receptors. When it binds to these receptors, it stimulates the muscle cell to release calcium and go through that whole chain of events. And then whatever's left in this space gets broken down by an enzyme. So there's nothing left in that space after a certain amount of time. Right. So that's actually, I think, where I'm going to stop. I didn't realize we were that close to that. So that's a lot, right? To go through that whole process. If you can keep that straight, right, you'll be in really good shape. If you can keep straight that the signal comes down the length of the axon, acetylcholine gets across the synaptic cleft, binds the receptors on the muscle cell. Those receptors generate an impulse, or the binding to those receptors generates an impulse through the T tubules. which causes the release of calcium from the sarcolemma, from the sarcoplasmic reticulum, which binds to troponin and tropomyosin, which allows for myosin to bind to actin, and the myosin heads can shift inward and pull the actin in closer. Right? Those are the events that you need to keep in mind for today. Now, what we'll do in the future, what we'll do on Wednesday is go through the contraction cycle a little bit, right? And the amount of tension produced, the muscle twitches, that kind of thing. And then we'll talk about slow twitch and fast twitch muscles. We'll talk a little bit about skeletal, or about cardiac and smooth muscle. And then we'll name some of the muscles. Okay. And I'll open up that document that has the names of the muscles so that we know that we're only naming the ones that are on that document. But I think we'll stop there for today. So again, there are some things on Pearson. I put stuff there for the rest of the semester now, so it's all there. Things might move by a day or two here and there, but that's easy enough to slide around. But at least you can kind of see what we're doing each week. Also, realize that the muscle lab is something that's on Pearson, on Mastering Biology, or Mastering A&P. I did just change it today so that you have multiple attempts at it. So it will only count your highest attempt, so it's not going to penalize you in any way for doing it a second time. And I moved that out to Wednesday, figuring that we'll lecture today and we'll go through lecture on Wednesday, and maybe, you know, that'll give you a little more insight as to doing that lab. The lab is basically, it's based around physiology kind of stuff, how the muscles contract. So I think that's about it. Are there questions that you guys have for me?
No, you answered all mine.
Okay, good.
You gave me a headache today.
Yeah,
I mean, with the density of the material.
yeah, no, it's a lot. There's
Oh
a
my
lot of
God.
little intricacies, and if you think about how
Yeah.
quickly muscles contract, right? Like as you're writing, taking notes, or as you're typing, all those muscles in your fingers are contracting within milliseconds. So that whole chain of events is happening in thousands of seconds, where you're getting the signal from your brain to your finger, and you're causing the release of calcium, and actin is, you know, opening up so that myosin combined to actin, and all this stuff is happening in a fraction of a second, which is crazy. It's crazy how quick that happens. But so we will meet again on Wednesday. I hopefully will have new links to Zoom by then, and we'll post them in your Moodle course and send out an email saying I posted new links. Please bookmark these links if you have the other ones bookmarked, so that we don't keep getting kicked off every half hour.
When are we going to use the package that we received for the lab?
That's a great question. Starting with the nervous system.
Nervous system.
So
Okay.
yeah, so if you go to the syllabus, the lab for the nervous system is actually dissection of a sheep brain, and that is probably the first thing we'll do out of that box. And so I'll do, the plan is that I'll do some of these things as demonstrations ahead of time and post them, and then we'll do the lab together. I'll have, hopefully some of you guys will be willing to do this kind of as we're going through this, right? And I'll be here answering questions and kind of showing you what my picture is and that kind of thing. You know, so that way at least you'll have a demo to watch, and then you'll be able to do it live and ask some questions, because it's always hard to show exactly where some of these little things are. The other thing that I did last semester that seemed to work out well was I had students take pictures at various points in the dissection. And I took pictures and posted them online as well, so that you could see what I was talking about, where the pituitary gland is, or things like that are really small.
I started to watch one of the videos you had posted up of the
Oh.
sheep dissection of the brain. I was at work. I was a little bored, so I just started scrolling through, and I saw the video. So I was watching it at work, and you could hear it halfway down the hallway of you describing, because one of the nurses came over and she was fascinated on watching it too. So yeah.
Cool. Yeah, most of those I did with my daughter who's 14, loves all that stuff. So we usually get relegated to the basement. My wife is not too thrilled that I have a sheep brain and a fetal pig and stuff in the house. But
My aunt upstairs wants to be here when I dissect it because she's fascinated with that stuff too.
yeah,
I'm like, well, I'll be doing it during class because I don't care. I'll stay quiet and I'm gonna watch.
yeah. And that's fine if you have somebody that wants to, come and check it out while you're doing it. That's fine.
Awesome. I was
Some
gonna
people are
ask
really
you that.
excited about it, and some people are really
Yeah,
not.
I have a
excited about
nurse
it.
who wants the eyeball.
Yeah.
She likes to dissect the eyeballs. So she was like,
Okay.
when you're done, can I have it? I'm like, I don't know if that's legal. She goes, I
Right.
like to really go through it all. And I'm like, okay.
Okay. I mean, I guess it gets
She said
shipped to
there's
your
like
house
a-
and it goes in the regular trash. I mean, there's not
She was-
anything harmful about it.
Yeah, she said because behind the eyeball, there's like it looks like a liquid thing. It was like it's like a purplish, like turquoise type look or something.
Mhm.
And she was telling me yesterday about it. She goes, I think it's fascinating having to get to that and everything else. And I'm just like, you're not right.
Yeah, at the back of the eye, you know how animals'
Yeah.
eyes like glow in the dark? It's at the
Yeah.
back of the eye is kind of this really cool iridescent, like this green blue color that
Yeah.
you
Oh,
can see,
cool.
like you can kind of see like, oh, that must be how it reflects light so that this animal can see better at night,
Oh, that's
Yeah.
cool.
It's pretty cool.
Yeah, so she's
can't
like,
wait.
when you're done dissecting your things, she goes, can I take it? She goes, like, she likes to take them home and go through it even more.
Uh-huh.
She's
I'm
gonna
like,
cook it. No, okay.
okay, more power to you.
As long as it's not a
All
person,
right.
right? That's good.
Yeah.
Yeah, no.
Well, no, she went to one of those ones where they have people donate their bodies.
Yeah.
She's fascinated with it. So now
Yep.
I'd like to check one of those out.
Yeah,
Those
those
are
are cool. The like bodies revealed exhibits and stuff. Those are really
Yeah.
cool if you ever get a chance to go.
Yeah.
I know there's a couple that travel around the country anyway. that are
There's
really
nothing
cool.
around here, huh?
There was one for years, for probably close to 10 years in New York City.
Oh, nah.
But it's not there anymore. I think it's out in Vegas now.
Oh, see,
There's
I,
a good reason to go on a
that
road trip.
that I'd like because I'm a visual, like a hands-on learner. So if I
Right.
visually see it and I'm actually like there, I can learn it.
But
So I just bought a bunch of those 3D things off of Amazon to help with like the skeletal and the muck, all that. So I'm waiting for those to come in.
cool. Yeah,
Nice.
the traveling exhibit moves around quite a bit. It's come to Connecticut a couple times in the past couple of years to the Science Museum and stuff. So I would imagine it's going to come to to Boston and stuff pretty frequently with so many schools and hospitals and stuff in that area.
I'll have to keep an eye out.
Cool.
So,
Yeah. All right.
All right, guys. Well,
All right.
have a great weekend,
me
and
too.
I will see you on Wednesday.
All righty.
Okay.
Everyone
Thank
have
you.
a good weekend and be safe.
You as well.